Okay, next I want to create our proxy geometry. So just to explain what that is, when we simulate, Bullet prefers to have convex shapes, right? So for example, this shape here we can see is definitely concave. We've got a hole going into the side there, right? And Bullet doesn't like that. It can deal with it, but it's not very good at it, and it's very inefficient also. So it's best to try and build geometry which has no concave inward facing parts like that, okay? And also just geometry with less polygons. So we can build other geometry which we will simulate, which looks like this, has this general shape, and then apply the transformations back to these to these shapes, right? So we don't need to do that to every piece. If the piece is very small, like these, it doesn't really matter. It's not going to affect the overall look of our sim too much. So I'm just going to drop a, not volume, sorry, a measure sub, and measure these by their area, the actual size of each one, okay? Not the area, sorry, the volume. So we need to go per, I want to measure each piece. So we're going to go per element and not position, sorry, per piece. And the attribute is going to be name. Okay, which we have. So that's going to go, so you can see we got all these different pieces there now. Okay, and I want to measure not the area but the volume of this. So it's going to give me values on my primitives of the volume. So you can see there for each piece we got values from 7.5 down to, you know, almost 0. Okay, so if we split this now, okay, so we're going to split the volume, split these into big and small pieces basically. So if I use add volume, so again it's like a quick if statement. If the volume is bigger than 0.05, then send it to the left. If not, send it to the right. Okay, so if I drop a null, you can see we got all these tiny, not tiny, but small enough pieces here. And then on the left, our bigger chunks. I'm just going to first of all drop a delete to get one of them. Just do a quick test. So let me grab, make a selection by, let's see, by the name attribute. And just grab one of these. Okay, press enter. Let's try that again. Click this arrow, select this big one here, for example, press enter. There we go, delete, non-selected. I can isolate this chunk. And then, yeah, so we need to make this into, as I said, convex geometry. So there's a new node for that, which is called convex decomposition that we can use. There are other methods of doing this. You can build it with just a load of spheres, which is also very efficient. Okay, but this is, so we'll use this new node, which is quite handy. So you can see as soon as I plug that in, it kind of plugs those sides in. Okay, fills in the holes. Now if I drop this, we don't need this segment attribute, so I'm going to turn that off, and I'm going to drop this down to 0.1. You can see we start actually getting concave shapes. But how this works is that it's building separate pieces of geometry. So these are all, it looks like one, but these are all separate pieces of geometry with the same name attribute, right? So they will be treated as one object in the simulation, but in fact they can be seen by Bullet as separate convex shapes, if that makes sense, right? Maybe if I don't know if this will work. Let's see if I can make a selection by 3D connectivity. Yeah, you can see we've got all these separate kind of block shapes. So these will be, you know, one hull in bullet, and then if we look at the name attribute, it's just one thing. Okay, so if we delete this, it will run through. It will take a bit of time, so I'm just going to set that to manual now. Okay, once I bypass this, it will run it over all of those pieces, and it can take a while. So I'm going to merge these together. Okay, so we need to now combine the geometry representation and the actual, kind of render geometry, if you like, together. And I want to cache them, so I'm going to use the abd.io for this, which will pack these together. And you can see on this import, we've got this proxy geometry, and then I'm going to take the original, like render geometry, and plug that into our first port there, and then we'll use this to cache this. So make sure we change this to save current frame. Everything else, leave it at defaults. Click load from disk. And then hip / I'm gonna save it in my geo folder / and then / we could say fracture with what's it called, the proxy, with proxy. Okay, and then dot video, and that's it. Okay, save to disk. Oh, sorry, before we do that, turn this off, visualize down here, and then set this to auto update. Let that run through. There we go. Once I put the visualizer on it run through, and it took a few minutes. So yeah, back down here, visualize that and save that to disk there.